If it was a job, it'd be called insubordinate. You can look that up later. And you get fired for insubordination. Well, it wasn't just one person. I had to tell multiple people when I walked around, put your phone on. So it wasn't just one, so don't blame any one person.
Good thing I know.
All right, so your exit ticket is based on mostly the first part of today. I'm not going to make it real hard because frankly, you need the grade. But I will tell you right now, there are a lot of people that weren't getting the easy part today. So you need to focus and put a little work in today. If you care about your grade. A lot of you may not. Oh yeah, thank you. All right, so we've done this before. This is not super new. We didn't call it necessarily what we're about to call it. That's the only difference. We said, well, if we've got an equation, right, and if we get more information about one of the variables, well, we can get rid of that variable. We can replace that variable with the number. I'd rather have a number than a letter. I'd much rather have, because then I could solve it. If I only have one variable in one equation, I can solve that. I can't solve one equation, two variables. We talked about that. There's too many different possible answers. We could graph it. A lot of you are trying to do cover up and solve. That's for graphing. That's not for solving. We want to come up with one answer for X, one answer for Y, and that will be the one and only answer for this problem. Well, we've actually already got one answer for X. They gave us the answer basically for what X equals. Technically, this is a second equation. So we have two variables and technically two equations, which is why we can really solve this. So all we do is we say, well, wait a minute. This goes back to my dollar bill and my 4 quarters example. If I have a dollar bill in this pocket and I have 4 quarters in this pocket, and I go into the store, can I pay with either pocket? Does it matter?
Yes.
They're the same. They're the exact same. X is the exact same thing as 2. It doesn't matter which one you have. They replace each other. So I can say, well, wait a minute. If I know 2 is the same thing as X, and I really don't want X in there anyway, if I can get rid of it, well, I can get rid of it. I can say, well, instead of having 5, this is 5 times X, if you don't remember that, by the way. So instead of having 5 times X, I could make it 5 times 2. Now, the rest of the equation I can't do anything with. A lot of you are trying to change the rest of the stuff. We can't change anything else. All we know anything about is just X. We know X is 2. I can solve that equation. Let me scroll down so I don't. So I could say 5, but actually I'm just going to skip that. 5 times 2 is 10. Plus 3y equals 16. Again, now that I got rid of the X, I have one variable, one equation. If I have the same number of variables as I do equations, I can solve. So I never divide or multiply in the middle. So I've either got to do addition or subtraction. Well, I need to do the opposite. So that's a positive 10. So I need to subtract 10. Our first step is always, when we get to two-step equations, we always want to start with the one that's just the number, not the variable one. Well, if I subtract 10 there, I got to subtract 10 there. I still have the 3y. That doesn't go anywhere because I didn't touch it yet. Last step is division. That's when we come back to division. So I get y equals 2, which some of you got. About half. Maybe not all in your first try, but. So the concept today is I don't think very difficult. The math gets harder. Like the math will get, this is some of the more difficult math we've done in a long time. But if you get the concept, and the concept is simply, I'm just replacing a variable with whatever that variable is equal to on the other side. That's all I'm doing. And technically, I guess I should say, and we have 2 equations in each of these problems, because we're dealing with a system of equations. The definition of a system of equations is you have more than one equation. We have more than one variable, more than one equation, more than one rule, technically, if we were dealing with word problems. So I'm going to take the information from one equation and plug it into the other equation. Just like here, I took the information from this equation, that x was 2, and plugged it into the first equation. So that's, you've got to kind of understand that you're using the information from one equation to help you solve the other equation. I think that's what kids were getting really confused on last class. I really don't know, because my first class didn't have any issues. So you guys might be the ones that kind of help me figure out where the roadblocks are. Because 5th period also only gets 45 minutes, so that's enough. Any questions on that? You will probably have something like that on the exit ticket, something easy. So all you gotta do is plug the number in and solve out for the variable. All right, so I want you to do the first one up there. The y equals -6, and then 3x subtract 6y equals 30. Same thing, same concept, nothing new from the bell work. I can't really zoom any more than that, because I don't want to go all the way into the 300. I'll give you a couple minutes, shouldn't take very long. I just did an example of how to do it. We've done this actually many, many times, plugging a number in and then solving for the other variable. You guys that are online, you're going to need to go in and download from Focus. You can try this one and then go into Focus and download the worksheet we're going to work on today. Oh, it's just one person. Got it. I totally forgot to tell last period to do that. Shoot. So, 2 minutes. Yeah, if you get done with this and the timer hasn't gone off, if you haven't gotten one of these packets, you can come get a packet once you're done. I'll walk around, see how we're doing on this one. At the very least, I hope you get the first step correct, is just plugging it into the right spot. So you have everything worked out except the math is off a little bit. That little challenge with the positive and negative stuff. You guys have got to try this. You can't just sit here with a blank page. Again, I may not walk around with my grade book every time, but it's not hard to remember that, oh yeah, every time I walk by them, they hadn't done a thing. So at the end of the day, I go back through classes and I get grades. That's what your weekly classwork grades and then your big classwork grade at the end of the quarter are based on. Oh, you did, this is multiplication. This is -6 times y. No, it's -6 times -6. Good. That's the concept part. You can't put these into the little calculators. That's why I'm not passing them out. They don't do it in the correct order. They just go left to right. So you have to know what order to do them in. Yeah, the little ones that I've got, you can't put it in because it doesn't understand order of operations.
Mr. Gill.
I'll be back over there.
Why'd you do that?
But then that's what he's tricky.
Yeah.
You need to replace this. Y equals that. You need to get rid of y and put that in. This is substitution. Word math is going to be off also.
Oh.
Because of the negative and positive stuff.
Yeah, negative and positive.
That's the negative and positive.
Wait, no. Negative is negative times a negative.
Good. Negative times a negative is positive.
It's positive, so this should be negative.
The number part's right, but see what you missed on the sign.
Yeah.
A negative and negative makes positive.
Yeah.
Yeah, it's below that under. Your second to last step. Yeah, your second to last step.
Same signs adding.
Well, if you came up with the right number, then you didn't come up with the right sign. It was after what you just said. It's not.
I don't know.
It's not negative. It's not negative. This is a negative 6 times negative 6. Or you can say subtract positive 6 times negative 6. So it's either subtract negative 36 or just plus 36. Either way, it comes out to be plus 36. If you do these left or right, it won't work on those. You have to make sure you put it in the correct order. So you need to make sure you start with multiplication, then come back and do the addition.
What is the second one?
All right, so a few of us were trying, some of us not so much. The more of these you do, the better off you're going to be for the exit ticket on Wednesday for you guys. Your exit ticket will be on Wednesday. 2 days, next class. All right, so I'm going to just show you what to do. And then we're going to move on because they get harder. We know why. But gentlemen, that's enough chatting. Even if it is about the problem, but I need to tell everybody how to do it. So y and negative 6, same thing. Doesn't matter which one I have. I could literally say, I don't want that there, I want negative 6 there. Because they're the same thing, replacing it. That's exactly what I'm about to do. If you need to erase and then replace with whatever's on the other side of that equal sign, that works. I'm not going to do it that way yet. I might actually do it when they get harder. So, I'm about to write y, correct? Or I just did. That's 6 times y, or technically negative 6 times y. But I don't want y in there. That doesn't help me solve. Having a variable in there does not help me solve. So I want to get this number in there. So I'm going to say, wait a minute, I know y is equal to negative 6. It has nothing to do with this negative 6, by the way. That's just a different number. It's the same number, but it's in a different space. It's not what y equals. This is y next, which would be times negative 6, which most of you, I think, had that down. You didn't get confused. And then this never changes. The numbers in there never change. 3x doesn't change, only the y. I have 3x subtract 6. Then I change the y, and then I still have equals 30. Only that y value changed, y variable. Now to do the math, which again, I'm not as concerned about this on the exit ticket. This is, you got to think about this as negative 6, because remember I said the sign goes with the number that follows it, times negative 6. That's positive 36. Some of you got a negative 36 there. That's why your math didn't come out right.
36.
And then that equals 30.
Oh.
Even if you said this, which some of you did, 3x subtract, and then you said, well, 6 times negative 6 is negative 36, that still becomes plus 36. Subtracting a negative number becomes a positive. It's a keep, change, flip thing that you did a long time ago, if you remember that. Anyway, I'm not super concerned about the math. If you had a good calculator, it would take that into account. We don't have good calculators. So now to solve this, I never divide or multiply in the middle. So I must have to add or subtract. I want to make sure my numbers are my signs are opposite, so they cancel out. Then that gives me negative 6 over here. And that gives me 3x divided by 3 divided by 3. Some of you didn't get a negative here, or you forgot the negative at some point. X equals negative 2. Now, I haven't been telling everybody to do this, but technically, we should plug this back into the equation along with the negative 6 and make sure the left side equals the right side to make sure our math is correct. Well, and you are in a crunch for time. I know a lot of the exit tickets and the tests and quizzes and end of course exams and all that stuff. You're going to be in a crunch for time. So if you have time, you could go back and do that. I haven't been enforcing it because it does take a little while to go back and do it. Any questions on how? Now that's the simplest problem we're going to deal with, is just plugging a number in for the variable. So if you have questions on that, ask now. It doesn't get easier. And I wish, and I know for a fact some of you aren't getting it. So if you asked a question, you're not the only one not getting it. Guaranteed some people are not getting it. Nobody wants to speak up.
3 minus 1 equals 2, right?
Right. 3 minus 1?
Yes.
Yep.
Okay.
All right, so here we're gonna get a little bit more difficult. Yeah, I'll do one more so that you can do a couple of extra problems on the, and then I'm gonna kind of do some, and then you'll do some on the worksheet, then I'll do one, then you'll do one or two. So here's the next kind. We have a variable all by itself again, just like we have y equaled something in the other ones. Here's the problem though, that variable doesn't equal a number. It equals an expression with the other variable. Same exact concept though, nothing changes. We're gonna get rid of the x in the other equation, so we're gonna use information from this equation to help us solve this equation. We know that x and 2y are the same thing. I could use either one of them. Thing is, I don't really have a 2y down here. Like there's no 2y that I could replace with just x. There's a 6y, but there's not a 2y. But I do have an x, so I could replace that x with that 2y, and that would get me to only one variable in this equation, which I can solve. One variable, one equation I can solve. So I'm going to write this in like short steps, which will hopefully help. So that's the equation.
Wait. That's the.
This means 8 times x.
Oh, okay.
This means negative 6 times y.
Oh, that's like.
I could literally say, well, I know that x and 2y are the same exact thing. And again, this means times, right? This means 8 times x. So if x and 2y are the same, but I'd rather have 2y in there because that would just give me just one variable. If I got rid of x and I had y there instead, something with y in it, I'd only have one variable. So let's do that. X is the same thing as 2y, so I'm going to get rid of that and replace it with that. I didn't touch anything else. Didn't touch anything else in that entire equation. I mean, if you have to write the equation out really big and give yourself plenty of room to erase and replace stuff, do it. But it's the same concept of erasing and replacing something.
So does that mean we multiply 6y2?
This 6?
Yeah.
Well, this is negative 6 times y. Is that?
No.
No, don't. No.
No,
You can say C didn't explain it.
Never mind.
So,
Never mind.
what was your question? You said, do I multiply?
Since
You
it
do
was-
multiply something.
It was x equals 2y, so I wondered, oh, since it's 2y, do we multiply the 6?
Here,
Yeah.
we're replacing x.
Oh.
X is equal to 2y. They're the same thing. If I would have said, if this would have been x equals 4, I would have taken x out and put a 4 there.
I was gonna.
So all I'm doing right now, I'll get to the math part in a second. You're trying to do some math you don't need to do, I think. First of all, we just replace it. This 2y has nothing to do with this. We're not even close to touching that yet. All I did is I say, well, I know x is equal to that. So I could get rid of any x that I see and replace it with 2y. Anywhere. Well, there's only one x. Right here. And this was 8 times x. That's what that means, 8 times x. So instead of 8 times x now, I have 8 times 2y. Now I could take the 2y out and put the x back in because they're equal. I could keep changing them in and out all I want. But we haven't gotten any math yet. It doesn't affect any math we do over here. Now we have new math we can do because 8x, we can't do anything else with that. That's just 8 times x. But I can do something with that. I can multiply the 8 and the 2. And I can say, okay, well, 8 times 2 is 16, and then it's still times y. Because that's still all of that. I mean, technically, this is 8 times 2 times y. We've just taken away the symbol right here and just made it 2y, but technically this is that. So all we did is we multiplied the 8 times the 2 and now we have 16y instead of 8 times 2y. This stuff doesn't change. We don't do anything at all with this yet. We can. We're about to. But you don't multiply that 6y times anything. It has nothing to do with the 2y. Now we can solve. We have one variable now. One variable, one equation. We can solve that. We need to combine like terms. Because remember, if I have the same variable, same exponent, which we don't even really deal with any exponents other than an exponent of 1 in this class, for the most part, I can take this and I can go ahead and combine these two. So if you have 16 yo-yos, starts with a Y, right? Well, I'm using yo-yo. I take away 6 yo-yos. How many do you have? 10. Well, then you got 10y. Think of them as, I've said this before, think of them as a physical thing. One of the other math teachers, that's the way he always teaches. He said, we're math teachers are just too lazy to write the whole word yo-yo out, so we just use the Y. Kind of works. Now my last step is division. It's always going to be the last step. So now I just solved out and I got Y. Yes, sir. I don't know. I was told I did talk to somebody about it. I was told they will be here today, but we'll see. I actually even emailed somebody. I talked to somebody else. So, all right. So here's the last thing. We're not actually done yet. Because when we solve for something, we want to know, like, what's our goal? What are we trying to do? More to it. What are we trying to do when we're solving? We have these equations. What are we trying to get? What's the end goal? We're trying to solve for both x and y. So we know y is what? Well, we're pretty sure it is.
3.
What's x?
3.
Do we know x yet?
No.
No, we don't know x. And the other problems we've done, they told us what one of the variables was. They didn't tell us that in this problem. They told us that x equals 2 times y, but that's not a number. That's not an answer. So we now have to figure out what x equals. If we know y is 3, I would take the easy equation and I would just say, okay, well, I know x then equals 2 times 3 because it's 2 times y, and I know y is 3. So x is 6. And I could plug both of these back into like this equation and just make sure it worked. Check my answer. Again, I know you're going to be limited on time, so I haven't been doing that. But you should, especially if you have a calculator, to work. Yes, sir. Somebody waiting for asking? I don't think anybody did ask. Did you ask or?
Yeah.
Oh, you did ask at the very, very beginning. You said after 2. All right, so you can go ahead and go, and then you can go after 2.
My phone's right there.
Got it. So here's what I want you to do. On the packet, if you haven't gotten a packet, come up and grab a packet. You can now do number 1. I already did number 13 for you. That was one of the problems on the sheet, you'll notice. So do number 1, number 15, and number 21.
You said number 1 and 15.
Oh, I see.
1, 15, and 21. 13, I just did. It's got, I mean, I didn't just do it. It's this one right here. The one we did a second ago. So 1, 15, and 21.
Can I do these on a separate sheet of paper?
Absolutely. I am not collecting this. I'm just going to walk around and give a grade for it because I want you to have this for the exit ticket.
Oh, is this like a study guide?
Basically, it's got, I guess I should tell you what's in it. If you'll notice, it's got all kind of examples in it. Like the first page has a couple of examples, and then it finishes, and there's an example here. I mean, you have like 7 or 8 examples in this packet of how different systems of equations are solved. Now, I will say most of them we're not even going to get into. So really just the first two examples are the best two examples. Yeah, really just the first two examples. We're not going to solve the equations that look like example 3, 4, 5, 6, and 7. We're not going to solve them the way they're doing it here. There's another type of solution we'll learn, and we'll use that one instead. Is that a math notebook? A math notebook? I guess, yeah, just copy it down, and I'll have to talk to Ms. Byrne. Other Ms. Martinez. I'll talk to her about getting you some help. All right, so I'll give you, how many is that? I gave you 3 problems. They shouldn't take more than 2 or 3 minutes. I'll give you 10 minutes, and then I'll walk around, and that'll be your first kind of part of the grade. No, just number 1, number 15, I think it was, 21. And 21. Yeah, just those 3.
I would never take.
For now. We're gonna do more of them though.
What they mean? Why is this blah, 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 blah?
Yeah.
The hardest one is number 1. So if you want to do 15 and 21 first, you can do that.
Can you help me on number 1?
I want you guys to try to figure it out first. I'm giving you plenty of time so that you can try. Again, there's an example. Example number 1, example number 2. They didn't give you a great example for problem 1 in the worksheet, but same concept. You have an example right here, though. I just did one for you. It's still up on the board. That's an example for number 1 right here.
Oh.
The math will be a little different, but the first part where you just plug something in is the same. Again, try to think about it. Try to come up with what you might be able to try. Don't be afraid to write something down and then have to erase it when I come around. Not a big deal if you have to erase something. Again, I cannot correct a blank paper. I can correct a mistake and help you understand, or really help both of us understand what it is that you need to correct. It doesn't matter where the variable is in the other equation. You can replace it.
Oh, actually, that's actually a value. That's not solar. Oh, wait, no, it is.
Because y represents a 1.
No, it doesn't represent a 1. It's just 2y is just 2 times y. We're not combining them, we're just taking away the math, the multiplication symbol. So technically, 16y is still 16 times y.
That's
We're
what
just
they taught
not
me
showing the
about.
multiplication.
That's what they taught me over there. Any like, if you got an x, but it's just a long.
Well, they're not talking about what y equals, they're talking about there's a coefficient in front of it, there's a number in front of it.
Yeah.
Technically 1 times y. I mean, but that doesn't really come into play in this problem.
Oh, no?
No, because we have a 16 there. Or we have a 2 there. Like, you don't have a 1 in front of the y, you got a 2 in front of the y. Or in below, once you do math, you have a 16
I was thinking
in
of
front of
that because you did the 8 times 2, which is equals 16, but that y, if I had a 1 in front of it, which represents a 1.
I mean, if that, I'm not positive what you're thinking is correct. So this is just saying, again, 8 times 2 is just equal to 16 times y. So all we're doing is taking away the multiplication sign because we don't really need it. We can just say 16y instead of 16 times y. Again, math guys are lazy. They're just trying to remove stuff that they don't really truly have to show.
I'm thinking too hard, that's what I'm trying.
Oh, there you go.
Oh, yeah.
But I need help. I'm still.
So here's 3x. You replace what with the 3x?
6.
No, you didn't replace 6. Because you still have the 6 there, right?
Yes.
So what did you replace with the 3x for the negative 2?
Which one?
What did you replace? You now have a negative 3x now. What was there? What was there before?
6x.
So what did you replace?
6x.
No, 6 is still there. You
Yeah.
replaced 6x. What did you replace? What was specifically there?
6. 5 minus.
So tired, I don't know how I'm still.
So what did you, the 6 is still here. So what did you replace?
I didn't go to sleep at all.
No, you replaced something.
I'm sorry.
I didn't go to sleep.
I want you to
I
write
stayed up
this
all until like 6.
right here.
Dang.
Rewrite it.
Somebody's gotta do it.
I'm doing this for reasons. There's a mistake that a lot of people are making. Gotta get this correct. I'm gonna show it.
Oh.
It was very
We have to
pleasant.
finish.
No, okay, so yeah, that's fine. So it's negative, right?
Again,
Negative.
and they put a
Now
six.
below that, I want you to write your original equation.
But I-
Oh, X.
There you go.
That's-
Is x somehow going to be equal to negative 3?
I went them, we went them. I thought it was two.
That even makes sense.
But it turns out they
Can
were-
3 be equal to negative 3
As a little
times 3?
baby.
Did you-
3 can be equal to negative 3 times 3. And 10 be equal to negative 3 times
There's
10.
other rappers too.
A number like x you can't take that and multiply it by another number and think they're going to be the same still. So that doesn't make sense. You're replacing the wrong variable. Y is equal to 3x. You need to replace the y. It's y that is the same thing as 3x, not x. X is not the same thing as negative 3x. You can't replace the variable with itself. That's the general rule. You can't replace a variable with itself. So real quick, I'm gonna go over something and then I'll come around and check again. I forgot to set the timer. We'll do 5 minutes. I'll start it after I finish this. So I need everybody's attention, gentlemen, especially you two gentlemen. Because if I walk over and you have blank paper, I'll be rearranging the seating chart right now. That's not working for me. So, a lot of people do this. A lot of people. Hopefully you got this. Oh, that's recorded if you need to go back and look at it. So let me, but I do have to unfreeze it. So here is the biggest mistake I'm seeing on the easy problems. Remember, this is going to be your exit ticket. What I just did, where the variable equals a number, but then this right here. Probably won't get any harder than this, but a lot of us are struggling on this. So I've got 8x, right? Subtract 6y equals 30. Here's what a lot of people are doing. They're saying, oh yeah, I got this x equals 2y thing down here. So I need to say, well, there's y, so I need to get rid of that and put 2y there. And then I got 8x over here, and then 30.
Yeah, that's what I was saying before.
What's wrong with that? What's wrong with what I just did? I just replaced the y, like we said, we need to replace the variable.
It's not an X. It's not an X.
Two things. First of all, did I get rid of a variable? If you don't get rid of a variable, then that should be your first hint that you didn't do something right. Because the whole reason we're doing it is to get rid of a variable. So again, I would be writing this down if I were you. If you go to replace something and you still have two variables, you did something wrong. Because the whole reason we're doing it is to get to one equation, one variable, which we can solve. I didn't get to that, so I did something wrong. Now the way I figure that out, and you can never, here's another general rule, you can never replace a variable with itself, with a version of itself. Y cannot equal 2y, because I'm basically taking a number and multiplying it times 2. How could those be equal if I just multiplied times 2? That doesn't make any sense. So I can't replace y with 2y. I can't go from this to that. I'm multiplying this times 2. How could they be equal? It's not possible. So, if I look at the problem, and I look at what is equal to each other, x is equal to 2y. I can replace either of those two things. So I need to either replace x with 2y, or somehow I would have to replace 2y with x, if I could. No, we don't have 2y in the equation. But theoretically, if you did, like let's say, actually you have one of these here, I don't want to get there yet. All right, go ahead and try to figure it out from there. We'll get to the next one in like 3 minutes. Try to figure it out. You can't replace a variable with itself, or really a different version of itself. And again, the second check is if you didn't get rid of a variable, you substituted it incorrectly. You got to get rid of a variable or else we didn't do it right. That's a battery. All of these answers should come out to be nice round integers. There's no decimals or anything in the answers. Yeah, let's see if you subbed in first. So that's where's your other equation? Like you wrote one equation, there should be a second equation.
On this one. Oh, I didn't see it. I didn't see it, sorry.
You know, somebody did get ones a lot in the other class, but I think there's some negatives that should be in some of these, if I remember correctly. But you're on the right track, because one, I believe, is the answer to a lot of them in some version. Like, need to be negative in some.
I don't get this.
So just go back, and they may all be positive. In all honesty, I didn't sit there and work through all of them with them. But go back and look at your positives and negatives, because that looks pretty good.
And number one, I just.
Well, that's the most important. I trust that you can do these, where y is equal to a number. Oh, you did the same thing. You can't replace a variable with itself. You replaced x with itself, 3x. Can't do
Oh, I
that.
have to replace X with Y?
Well, other way around. You got to replace the y with the 3x, right? Because we know y is equal to that. So we need to erase y and put that in there for it. Or y is what you're replacing. Got a question? Or you sure? Yeah. Put your phone in the middle, please.
Did I follow the order?
First, you got to show me that you can substitute in correctly in the right spot. No. No, you're not replacing the right thing. I'm going to give you another example. Here, I'll use this same one. Let's say this was our equation. Instead of this, so this is going to be more like the one you're working on for number one. So that's one equation there. Our second equation is that. All right? So that's kind of similar to the one you're doing on number one. The y is all by itself in both of those on the left. I have actually two options in this, because I know that x is equal to 2y. I also know that x is equal to 5y plus 6. And that's possible. They could be, x could be equal to a whole bunch of different types of expressions or equations. I could do one of two things. I could say, well, I know if x is equal to 2y, I could get rid of this x and replace it with 2y. Because they're the same, right? So instead of having x here, I could have 2y there. Then you have to solve it out, and like I said, the math part gets a little tougher. Or I can actually go the other way with it. I know that x is also equal to 5y plus 6. So I could get rid of that x and replace 5y plus 6 up there. They're again, interchangeable is the best word, but I don't know if that helps you guys. I can switch out whichever x I want for this. Now, obviously, I can't switch this x out for this and say 2y equals 2y. That gets me nowhere. Technically, it's correct, because this x is equal to 2y, so I could say 2y equals 2y, but that doesn't do anything. It doesn't help me solve anything. So that's why I need to go to the other equation when I switch it out. And I could say, well, this x is also equal to 2y. Basically, everywhere I see x, I could put 2y there instead. So I could go to this x, erase it, and put 2y, and then I only have y in this equation, and I could solve out for y. Now, the solving part gets a little tougher in these. But I'm more concerned that you're substituting in the correct place first, because most of us are not. You do it fine when there's a number there, but for some reason, when it's no longer a number, we're struggling. You get rid of the variable, you literally erase the variable, and then you take whatever that variable is equal to over here and you put it there in its place. So try it again. I gotta come around and check, and then we gotta move on. Oh, I never started the timer. Oh, did you get, so you need to get this packet.
Yeah.
Packet right there. I'm coming around. Just,
I can go to the bathroom, just come back.
oh, yeah, you can do that. So that's what somebody else got with all ones. Seems odd. I don't know. I haven't solved all of them out. I'm just more looking at the steps. But how many steps look pretty good. I could have sworn somebody was getting negatives though in another class. I think I do have a answer sheet, so I'll look for the answers in a minute after I do some more examples. Which one? Oh, we're oh, okay, so you plug it in there. Now, once you plug this in, there's no Y. There's just a number. Like you just did, like you did it correctly. You plugged it in right, but then for some reason you added the Y back in. The Y is only there if you're like if it would have been Y equals negative, and Y is gone.
That's illegal.
So you plug a number in. Let's get that.
Okay, I think I did it right.
So, Aaliyah was getting all positive ones. So that might be right.
Okay, just give
Well, I got a question.
I have an answer sheet that I'll look at once I let you guys start doing the next round of problems. So, plug in. No, wouldn't be. If what you're plugging it in would be X. Y is -5, not X. Plug -5 in for X. That would be -2 times just 7. So it'd be -2 times 7. It'd be a
It's
negative.
nothing to put like Tide Pods in there, and you forgot to take them.
So you're doing this one right here?
Yeah.
Yeah, so the
Yeah.
Y on this side
It's
would
mostly-
replace,
it's mostly-
and then that equal that, and then you gotta try to solve that. But again, this isn't just subtract 6x, not subtract 6. You get, this is 6 times x, you subtract that whole term. So we need to subtract 6x over here. Which would give you -9x. I'm more concerned just about the substitution problem.
Am I doing nerds on the substitution?
All of those things. yeah.
Well, it wouldn't be 3, that's 3y. No, you can't replace y with itself. What I just said.
I'm gonna watch my
Y cannot equal 3 times y. That's like saying this is 3, and that's the same thing as 3 times 3. Which isn't true. It's like saying 3 equals 9. Never replace a variable with itself. That's not what y was equal to anyway. What is y equal to in that original problem? There's actually one person in line. You can go after them. I think.
Is that a good start?
Maybe a Leah.
Oh gosh.
No, you're replacing this. Y is equal to this. Erase y and put that instead.
Oh, see, just like this.
You can, yes, absolutely. I'm gonna have to make all of you do that apparently.
No, look.
I got half people that can't even plug it in the right spot.
I gotta put this.
This doesn't change. This changes, the y changes. That's 6x in my mind, doesn't change.
What?
It's all one. You gotta know how to do number one, the one to one.
But wait, we got 3 extra things.
You got number one.
Yeah, so.
Okay, look.
Wherever you see y, you put negative
So,
What?
You gotta keep those next. I didn't finish.
Again, this is the y. That's what you need to replace with that. Everywhere you see y, you can put negative 3x instead. All right, one more time, everybody this way, and then I gotta move on. We're still struggling, and help me, I don't get it. I don't get it, but tell me why. You gotta say, I don't understand this or that. I say, do you have any questions? And nope, nobody's got a single question. And I know you're not all getting it, but nobody's willing to say anything. You gotta get over that. You've got to ask, I don't get this part, because you're not the only one. Trust me, I'm seeing what people are writing. Most people are not getting it. You're not the only one. If I have this equation, so I'm going to keep it the way it is with the green equation now. So I have x equals 2y, but x also equals 5y plus 6. Anywhere I see x, I could take it and replace it with 2y. We'll go to the other equation. I see x right there. So I could replace that with 2y. You guys are plugging in the same variable with the same variable. You can't do that. And then you still have 2 variables left. So again, I'm going to rewrite this up here. I mean, again, it's going to get harder. This is the easiest thing we're doing, other than just plugging a number in. If I see x is 2y, what this means is anywhere I see x, anywhere, because x has always got to be the same thing, it can't be different things. Anywhere I see x, I can put in 2y instead. Well, I could put it here, I just said that, but that doesn't make sense. Why would I want 2y equals 2y? So don't do that. Where else do you see x? Joe, where do you see x? Where else do you see x in that equation, the 2 equation?
On x equals 5 and x equals 7.
So we see x down here also, right?
Mm-hmm.
Again, anywhere I see x, I can replace it with 2y. So I can replace this with 2y. What are you gonna do? If you see y, so in the first one you're working on, it says y equals negative 3x. Anywhere you see y, you can change it to negative 3x. You're all trying to put it on the other side of the equation. You're all trying to replace the x with negative 3x. Well, not all, but a lot, way too many of them. Anywhere you see the variable y. Now, it doesn't make sense to write negative 3x equals negative 3x. Just like here, it doesn't make sense to do 2y equals 2y. But in the other equation, where you see a y, replace that with negative 3x. All right, so I got to move on. You guys are going to be responsible for this, and more importantly, the exit ticket, which is going to be one of the only easy exit tickets that you're going to have this quarter. You might have 2 easy ones. So if you're not getting this, you need to rewatch this, put some extra time in, look up some other videos. I mean, there'll be 100 videos if you type in solving system of equations with substitution. They're all going to do the same thing we're doing, but if you want to watch somebody else solve it, you can. Maybe just seeing it more times, it'll sink in. So let's do one like this. Like I said, that gets a little more complex. Actually, it doesn't even get that much. It's the same thing over and over. Here, good. I'm moving on to the next type of problem. So it's
easier?
No, it gets harder. I mean, easier. This is actually about the same. The math gets easier, but the concept is no different. Let me do this real quick. So again, I know y equals that. I also know y equals that. Anywhere I see y, I could replace it with this, because they're the same thing. That means I can replace it. Or I could replace it with this, because y also equals that. Let me just give you an example. Maybe this is confusing you. 9 equals 5 plus 4, right? Well, 9 also equals 3 plus 6. 9 also equals 2 plus 7. Y can equal a whole bunch of different things as far as an equation goes. There's all kind of things that can eventually add up to whatever the number y winds up being. Maybe you're stuck on the fact, I don't get how y can be two different equations. Well, the same way 9 can be 5 plus 4, or 3 plus 6, or 2 plus 7, or 3 times 3. Or a negative, it could be subtraction. It could be 20 subtract 11. 9 can be all kind of expressions. So y can be all kind of expressions over here. They all will equal the same thing if you did the math. The key is, I need to take what y equals and say, okay, well, I'm going to replace y, wherever I see y, anywhere, I could replace it with one of these two things, because that's what y equals, both of those. It doesn't make sense to replace it in the same equation, because then I just get this equals this. Same thing. So let me go up here and replace it up here instead with negative 2x subtract 22. And now I have a new equation of negative 2x subtract 22 equals 3x plus 13. Now I only have one variable in that equation, just x. So I can solve that. I'm not even worried about you solving at this point. I just got to get you plugging in the variables in the right spot. Well, unfortunately, they don't have a whole lot of examples on here like those. It's only number 1, really. Oh, wait, no, that's not true. That's not true. So here, I'm adding some that you can do to the 3 that you're supposed to have just done. So now, number 2, 3, 4, really, the next, all the way through 10. So 1 through 10, you're responsible for trying now. I don't expect you to finish them all in the next 10 minutes, but I'm going to walk around in a minute and make sure that you're getting at least where to plug in. Oh, tell you what, don't even try to solve them. I want you to just substitute in. Just substitute in. You don't have to do any math. That you should be able to do in 10 minutes. So just substitute in the right expression in the right place in the other equation.
Wait, I got a question before I do this.
Yes.
X plus 5 is just going to be 5 for x.
Well, how we don't know what it is. X is x. You don't know it. Write the other equation, and then we'll work through it. We only know what y equals. We don't know what x equals. We know what the variable y equals, and we don't know what it equals in a number. We know what it equals in another expression that just has x in it.
Like this?
Erase that second line. I didn't want you to do it.
Yeah, like this.
Yeah, y equals that, so you just say, okay, instead of y on the left, I'm going to get rid of that. I'm going to put what y equals.
Oh, really?
I'm almost done. I gotta do this one.
All right, so we got these two equations, right? That's what they gave us. Now we know y equals this, right? But we also know y equals this. Anywhere I see y, the variable y, I could replace that with either this or this, because y equals both of those. Now, it wouldn't make sense to just replace it right on the other side and have x plus 5 equals x plus 5. You don't want the same equation or same expression on both sides. But I could take one from one equation and replace it in the other equation, or this one replaces that one. I want you to try to change one of the equations so that you have only x left. And I'll come back and check it. Just remember, anywhere you see y, you can replace it with what is on the other side of the equal sign.
He does.
Perfect. So I want you to try to just replace, without math. I mean, you did this one right, you replace it, but I want you to do one with a variable number. Do one where y equals something with a variable.
And those would be like document.
Try one of those.
Just that one.
No, this wouldn't change. It wouldn't change this side of the equation.
So it would be this top X.
You're substituting in. What does y equal up here?
X plus Y.
It's the same, so why don't you just put x plus 5 up there? Get rid of y, put x plus 5. That's all you're doing. You're getting rid of one of the variables. In this case, the only one you know something about really is y. And then that just equals whatever was on the other side of the equation. You don't change anything on the other side. You're only changing something where the y. So that's your equation.
You leave it like that?
That's it. Well, I mean, we'd solve it out eventually. I'm not worried about solving right now. I need you to do more substituting, so I can make sure you got that
Oh,
one.
Miss Gibbons,
Then we'll come back to
so
substitution.
far, am I doing it right?
Yeah, because she keeps hitting.
So you're taking the y out, placing that there.
Yeah.
That looks good. Now we wouldn't want the same thing on both sides. So it looks like you wrote, it looks like you wrote the same equation. Oh, is it?
Yes.
They gave you the same equation?
Which
Which one is that? Oh, okay. All right, then yeah, that was a different equation. Yeah, that was good. And then, once you get done doing that, you can try to solve it, because the math does get a little tougher. Because you gotta move variables to the other side of the equation.
New line.
No, maybe really just. Oh, when you come, I just.
Are we doing 7, 8, 9, 10?
You do 1 through 10.
Oh.
Yeah, that's good. That was good.
That's all you get to do. We're not doing that.
Literally take y out. What
Tournament ended
With
at
Right,
1.
like,
The tournament ended at 1.
Yeah.
the y all by itself? Like, why are they all in like that kind of slope intersection? I don't know. Just, I guess they felt like you were gonna run into that a lot, because we were just doing graphing. And that's one of the core, I'm teaching the graph, so I guess
Well, I
I'm
can
trying
teach
to
you too.
keep it similar to what you
I
solved
can teach
before.
you.
They won't all be like that. If you look at the later problems, they're not all like that. They start to get harder.
So it's,
No, it's not graphing at all.
Yeah.
Graphing is one way to solve. This is another way to solve. Remember how we said on a graph, if the lines don't cross right through the corners and squares, we really don't know what the solution is. We can't estimate, like maybe it's 2.5 or 3.5 or 2.2 or 2.4 or 2.6. Well, this way you get an exact answer. You'll get a number that is an exact answer.
Get done with stuff.
Well, right now, you're just replacing, you're substituting, not doing any math. So did you, so let's take these. So you have this written on your paper. Right?
You should.
I need to say, okay, I know y is equal to this, but y is also
You
equal
have
to
to
this. Anywhere you see y, the variable y, you can replace it with this, or you can replace it with this. Y is the same thing as both. Now, it's fine that there's two different expressions, just like I said, 9 could be 5 plus 4, 6. You could have different expressions that equal y. As long as there's two different halves.
Oh, yeah.
What you need to do is say, okay, well, what would make sense? I'm going to replace one of these y. Which y would I replace with what? Perfect, yeah, because you never want to put the same thing on the left-hand side. That wouldn't make sense. So there you go. And do that for all, that's all you do for the first 10, really. And you've already done really one of the first 10, I think, or a couple of them.
So this is the first.
But again, y, right? Anywhere you see the variable y, you could replace it with negative 3x, because that's what y equals. Y is the same thing as negative 3x. So you need to say, well, where else do I see y? Where else do you see y? In those two equations, where else do you see y in those two equations?
So they would be like this.
Well, not negative 3y.
Yeah.
There you go.
Oh, okay,
That's
okay.
all you're doing. Anywhere else you see y, you can replace it with that. So now, so let's look at one here. So we know y equals this. Anywhere else I see y, I can replace it with this, right here. Well, where else do you see y?
I see why, or negative 2.
Just point to it.
Just negative 2x.
Where do you see y? I'm saying it just the variable y. Where else do you see the variable y? Well, no, but here we're already using this. We know y equals this. Where else do you see y besides that equation? Yeah, and that other equation, right?
Mm-hmm.
So you would say, okay, well, I can replace that y with negative 2x subtract 9. So you would just replace that y that's on the left with negative 2x subtract 9. So go through and try to do all of the substitutions you can. If you get done with substitutions, you can try to solve after that. Like, I'm not telling you don't solve, but I just wanted you to first get the substitution down. So that's good. So I mean, as long as you're getting the concept on one of them, you should be okay on all of them. I don't know which one you're working on, but I don't know.
Oh,
So I don't know how many have you done?
this here.
Oh, they're down here. Okay. Yeah, I mean, so all you're doing is say, okay, well, I know this equals that. Well, where else do I see y? Well, right there. Well, I'll just plug that into y. And now when you solve, like I said, the math gets a little tougher because you got to move x's to the other side and all of that. But right now, I'm glad we're starting to come around to getting that. So try to solve something. So when you get an equation, once you have an equation set up, so here, I'll do this one. I think this is on the sheet. So I'm going to wind up doing one for you, the math for it. So everybody look at whichever one somebody can find it on their paper. This is on your paper right here. This one that I'm erasing. So somebody find that one for me while oh, here it is. Which one is this on your paper? It might be farther down than 1 through 10. I don't know where it is.
6.
Is it 6? All right. So I'm just saying, okay, I know y equals that. Anywhere I see y, anywhere else I see y, I can replace it with that. Well, where else do I see y? Well, I see y right here. So I'm going to replace this y with that expression. Let me give myself more room. So I replace this y with that, and then I still, on the other side, I have the exact same thing. I don't change that at all. A lot of you are trying to change that one too for some reason. All I did is replace this y. I didn't touch the right side. Yeah, I need you definitely paying attention on this because you haven't made much progress. And I have a feeling there's a reason for it. But you look really guilty. I feel like every time I look back there, you're looking down at something that's not your paper. I hope that's not your phone sneaking out, especially considering this class's status right now. All right, so I now need to say, okay, how do I solve this thing? Well, I can't do anything with this because this is a term with an x and a term without a variable. Can't combine those. Again, same thing on this side. Term with a variable, term with no variable. I can't combine those. So I need to get all the variables to one side. I always get them to the left side, which means I need to get rid of them on the right side. Getting them over to the left means getting rid of them on the right. Well, the way I do that is I got to figure out how to cancel them out, which means I do the opposite. I don't divide or multiply in the middle. It's kind of in the middle, even though it's really the beginning for this one. It's two-step equation. That will cancel those out. 2x subtract 2x is 0. They cancel out. I'll still have the negative 22. I didn't do anything with that. If I add 2x, though, I've got to add 2x over here. Again, just a two-step equation. We did these forever. Well, actually, technically it's not. Now it's a two-step equation. So in order to solve for x, I have to say, all right, well, I need to get rid of the term that's the number first. I always save the term with the variable for last. Subtract 13 gives me negative 35. 5x equals negative 35, so my last step is division. Divide by 5 on both sides, I get x. Somebody I think I saw had this. X equals negative 7. Although you wouldn't even, oh no, this was number 6. You would have done it. So I'm not done though. That's the only thing. Because remember, we want to know what x and y equal. They didn't tell us what y equals. They just told us y equals this whole thing right here. But that's not good enough. We want to know the number y equals. So I got to come back over and say, well, if I know y is equal to all of this, now I know x is equal to negative 7. So I can just take negative 7 and plug it in for that x. So y would equal 3 times negative 7 plus 13. So y would equal negative 8. So your answer is x equals negative 7, y equals negative 8. Again, I'm not super concerned about you getting all of the math correct, but you should be able to get like the first step or two correct. You should know that, well, I got to somehow get the variables to the same side. Hopefully you work your way down and get an x. Then you need to remember, okay, so let me talk about on a quiz what I'm going to grade. Let's say you solve this out and you get the wrong x. Obviously, if you plug it back in, you're going to have the wrong answer for y too if you get the wrong x, most likely. If you just show me though, like let's say you came up with x equals 2. Like you solved it out, however you did it, you got the wrong answer, x equals 2. If you just show me though that you know you are supposed to then come over here and plug in 2 to try to solve for y, I would give you full credit for solving for y. Because you did the right thing when you solved for y. You took what x equaled, you plugged it in, then you did the math and you said, well, 3 times 2 is 6. So y equals 19. That's wrong, but it's not wrong because you did it wrong. It's wrong because your original value is wrong. You did everything right over here. You plugged this in correctly, you did the math, and you came out with the correct number based on this number. So you could still get the first variable wrong and get actually better than a 50% on the problem. That'd probably be a 75% or more if you did some of these steps right initially, like you plugged it in the right spot and you just made a math error. So again, make sure you're coming back over and solving for the second variable so I can give you credit for doing that, because that's the easy one normally. The math on that's easier, just plugging a number in and then doing the math. All right, so your assignment is, am I going to give you anything else? I gave everybody else 1 through 20.
Oh my God.
Tell you what, I'm going to show you one more thing. I'm going to actually do one for you. Everybody look at number 17. You do not have to do the math on 11 through 20. You just have to plug in the correct, or you have to make the correct substitution.
What's that?
So look at number 17. Everybody look at number 17. I'll give you an example of all you have to do, and one of them will be done for you because I'm about to do it. So on number 17, somebody tell me what the equations are.
Y equals x.
6x? Wait, y equals, that's number 17?
Wait, no, it's minus
Oh.
2x plus 2y
Wait, so
equals 8.
one at a time. Say it again. Joe, start over again.
No, he's thinking about y.
Oh. top equation didn't start with y.
17 is negative 2x plus 2y
Equals what?
18.
What? And then the next one was y equals something.
7x plus 2.
All right, so we have those two equations. All you have to do to get credit for 11 through 20 is this one step. I know y equals this, right? Y is equal to that. Everywhere I see y, I need to plug that in instead. So, I don't want to plug it in for this y because I'm in the same equation. So there's only one other place I see it, which is right there. I don't change the negative 2x. I don't even change the plus 2. I do change the y. I need to get rid of that y and plug that in. So you would do parentheses here because you want to show that you're multiplying 2 times all of this. That's all you got to do. You don't have to do any more math. I should make you do the distributive property because you should be able to do that, but I'm not even worried about it right now. We got to get this substituting in the right spot down first. Then next class we'll go more into math. So that would be all you would have to do for a problem like that, where you're plugging into the middle of the equation, whatever the variable equals. So I just said, okay, well, I know y equals this. So I said, well, in the other equation, where do I see y? Well, right there. So I just take this and plug it in for that. Nothing else changed. Negative 2x plus 2 equals 18. None of that changed. Just the y. So let me show you what we just did real quick. So we just took the next step. So this is I just did number 17 for you. Right there. When you go to 17, I'm not even making you solve it out.
Okay.
All you have to do is say, where do I plug in if y equals this? Where do I plug this into the other equation? Well, there's y. So I just take that out. I put this in, which is why I have parentheses there, because that was where y was. All you have to do. No math at all after that. If you want to try to do the math, because you're going to do it eventually, you might as well try it if you think you've got the distributive property stuff down. I'm going to walk around in a couple of minutes and start seeing how much you got done. I'm going to that. 11 through 20. Then I just did 17, and I think some of them are not all just like that. Some of them are like the other ones. Maybe even there might be an easy one in there. Yeah, well, number 13 I did for you. Number 15 is easy. And then all the other ones are pretty similar to what we just did. Again, anything 11 through 20, you don't have to do any math. If you want to do it, it's not a bad idea. But all you need to do on 11 through 20 is just plug it into the correct spot. Substitute it in the correct spot with the correct thing. All right, so I'm going to walk around and see how you're doing. I hope you got a few of these done, because I see a lot of people still have the same problem you've been on for like the last 45 minutes. Even if you have something wrong, that gets credit. Sitting there saying, yeah, I don't know how to do it still. Well, we're 45 minutes into this. Should have something. 11 through 20, just substitute it. I mean, ultimately, yeah, you're going to have to know how to solve it. Like for the exit ticket, I'm going to make you solve. But they're also going to be easy on the exit ticket to solve. All right, let's see what you guys have.
Oh.
you did all these. So I do, you need to know how to solve. I'll take, I told you, just do that for now. Very steep. If you want to do the math, like I said, it's not going to hurt you to do the math. Yeah, you should try the math too. You should be able to do
Recycle.
Now, when you plug in, you shouldn't have, remember, you should not still have two variables left.
Oh, so I can't, oh, I know.
So you're plugging it into the wrong spot. So you need to figure out.
Yeah, I'm on.
Baby's blood.
You've been doing have.
Think about it. Give it a long.
So I'm gonna have to change that senior. I was hoping that would be a good one for you to help each other, but it's not. It's a distraction. Not
Well, how did I know? Hold on.
Did you grab a packet? How do you feel on these? Like you get where you're supposed to plug it in? And it's really the same concept. It's just you'll have something, put something. Although, yeah. So again, if you're doing this, you plug it in. You don't need lines. You're replacing it, or you're literally taking it away and putting that in.
Don't throw it away.
Just remember that, and you're I think you're good.
A potato.
Yeah, that's it. You just literally get rid of that and put in parentheses what it is. Good. Good.
Deal.
I ain't quite.
Can I have my balls on?
He threw it away.
What? After recreating.
Yes, it took forever to.
Every time I walk by, they do the same thing. Gotta try to go. You just sit there staring at the same problem. You don't know how to do it, move on.
Oh, yeah.
You do one of the 15 or 11 through 20.
It's just the same thing.
So you're doing. Yeah. Yeah, so you're taking this, now wait a minute. So you're saying.
I literally just pulled it.
Yeah, you're kind of the right concept, but this is what y is. So you then say, well, everywhere I see y in this equation up here, I need to plug this in. And you somehow were trying to go from this equation to that equation. You wouldn't really be able to do that.
What's the
You're done
date,
with
Shelley?
Yeah, I'm walking around checking right now. Any of the ones here, yeah, this is it. No, this isn't the same, you can't put it on the other side of the equation.
No, it's called.
And that's what I did up there on 17.
Oh, do you do a rotation?
It says the exact same thing as.
We need to take this out. This is where we see y. So y is equal to this. So I look at the other equation. Well, where's y? Well, here's y in the other equation. That's where you replace it. On the other side. On the other side, you're just gonna have 18. There's no y over here. So you need to like make parentheses. Well, I did it up there.
Dude, you know that one guy that dropped off the counter that says I'm gay.
Right? That's better though. It's a little bit better to come back and say further though.
Ball stinky. You're disgusting. Shut up, you wrong.
So if you want to work on the math on those, you can. Now, once you replace it, you don't need the variable. You're replacing y. Remember, you get rid of it. If somebody subs in the flag football game for you, you stay in? No, you come out. You sub something in for y, you got to bring y out. And get rid of it. Good. So yeah, you just take that out, and plug it in.
What, dude?
So what would you do here? I want you to do that one real quick. So that can kind of be a big part of your grade.
Do I put the X right next to the 2? Like, do I put, this is y equals this? So, do I put that, yeah, thank you, Bree. I put,
Well, you wouldn't want to just say 2x subtract 1 equals 2x
Can you check it
subtract 1. That doesn't make it.
but I put this right here.
No, that's what I just said. You don't want to replace, this is what, like, which one are you saying? This one. Yeah, you could do this one down here, yes, correct. The whole thing, not just the 2x, the whole expression.
Oh, look at one.
So,
9.
It's not working.
again, we know y is equal to 7, right? Where do you see y in the other
Okay,
equation?
look at my iPad.
No, that's one of your. Where do you see y in the other equation?
I don't know.
Then, you want to get rid of that y. Yeah, that's what y is also. So you literally, you could just erase that, and then write all this in. But you
Bro,
look
yeah,
at
all
some
this
design
around
right
right
now,
now.
show that it stands for just the y.
What the fucking thing?
Oh my
Oh, excuse my language.
Yeah, I did hear that.
This is very hard.
Excuse me. Then I need to.
Oh, I got you. Aaron.
Censorship.
You made me
Since I
spend a
put
little
the
time
high
coming
back
in.
Well, you're all taking
On the
home, but you need to
Photoshop
spend a little time probably after school with me. But I don't think you're getting the last couple lessons done.
How much time do we have? What time?
2 minutes.
You know what I
Oh,
could
we
do?
have 2 minutes?
Oh, yeah.
Imagine after school, and they were for football games in the field.
I can do that, right?
Oh.
Wait, what's your history check?
Mr. Gill's math class. I'm gonna have Mr. Gill's channel.
This is a picture of a dog. Like, don't find pictures of Mr. Gill.
Yes.
Is it okay if I look up your YouTube channel?
Mr. Gill, what
I
happened
would love
if
you
I
to
leave
know my
a
YouTube
dislike on all your?
That's what it's here for, it's so you can do
Everyone-
reviews and lessons.
Everyone subscribe to his channel so he can become the.
I had it on the bell work. Oh, yeah, I can stop the recording, yeah.
When are you gonna post it?
I have to go out to tennis practice today, but I'll try to get it posted before I get out there. Problem is, it takes a long time to post. So hopefully you downloaded that, Kylie, and you're working on the packet. It's due for you, we'll just say the end of the week.